Okay, we are going to be looking at some domain and range things today, um, and looking at different functions and kind of trying to figure out how all of that works. So it's a little bit tricky, but we can do it. Okay? So first of all, we're going to be looking at functions today. You need to know that functions is kind of a way that values of one variable depend on values of another. We're looking at this function machine. And what a function machine is this. You input values into the function that won't ruin your machine. Sometimes there's rules to that. And then that machine takes it, manipulates it, and gives you an output or a result. Okay? For instance, if you're looking at the area of a circle, you can't find the area of a circle until you know the radius of the circle. And you know that radii, have to be positive values. So I can't input a negative value into the function machine whose formula is the area of a circle. I can't put that in. I can only put in positive values, and clearly I'm going to get positive values out when I'm dealing with the area of a circle. So those are that is one kind of an example, okay? In this particular function machine, the function that you're going to perform is to add 1 to every variable that you input. Well, if I'm telling you that you can only input odd numbers, so you can only input 1, 3, 5, 7, and then in your machine you're going to add 1 to them, well, 1 plus 1 is 2, 3 plus 1 is 4, 5 plus 1 is 6. If you think about it, the only thing you're going to get out are even numbers, okay? What you input is the independent variable. What you output is the dependent variable. Also, what you input is your x values or your domain, and what you get as an output is your y values or your range. Okay? So, when we think about this, I am designating here your input. Okay? So here I'm telling you on this one, and I'll sort of record this for you so that you can see that. I'm telling you that your input can be odd numbers only. This right here is going to be your domain. Okay? This is the domain. That's what I'm worried about here. The only thing I'm telling you can input is odd numbers. You would record that like this. The set of all x such that x is an odd number. Okay? Your output, we already talked about. Your function machine tells you you're going to add 1 to every single input that you put in. So when you add 1 to 1, you get 2. When you add 1 to 3, you get 4, da 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 da. Your results, or in this case, your range, or your y values, you're always going to get a result that is an even number. Your range is your y value, so the set of all y's such that y is even. I'm just going to write that since I'm running out of space. Okay? All right, on to the next one. This time, this is your function. Notice it says f of x, okay? F of x is always your result. What do you get when you put a number in for x? So you go to the other side of the equation, and I want you to think about numbers that you can put in for x, okay? Now, you're trying to take the square root of a number, okay? When you take the square root of a number, you can take the square root of 4, you can take the square root of 1/2, you can take the square root of 986, you could take the square root of pi if you wanted, you could do all of that. But what you can't do is you can't take the square root of a negative number, okay? So that's one of the things that you want to look for when you're looking at domain, is numbers that are underneath radicals. You cannot have negative numbers underneath radicals. That does not work. So the only things that I can input to this machine are numbers that are 0 or bigger. I can also take the square root of 0, okay? Here's how I would record my domain, just so you know. I could record it a couple of different ways. I could just say that x has to be greater than or equal to 0. That's one way I could do it. Or I could say that x has to be from 0, and 0 is included, so that's why it's a bracket. It would be a parenthesis if it's not. All the way up to any positive number would be up to positive infinity. That's one way I could do it. Or I could even write a sentence and say the set of all x such that x is 0 or bigger. I could even do that. Or x is a positive number. I could do that also. Okay? Now, when you think about it, if you take the square root of 1, you get 1. If you take the square root of 1/2, you get 1/4. If you take the square root of 16, you get 4. Notice that those are all positive numbers in this case. And we will talk about that in a minute. Right now, we are really and truly only worried about our domains, okay? I want to, in this case, talk about range, okay? And range is your output, again, what you get for your output. This time, notice your function machine would be this, okay? So I could write it as a function like this. F of r equals pi r squared. Okay, I can't find f of r until I know r. So I need to think about what kinds of numbers can I plug in for the radius. Okay, this is the formula for the radius of a circle. Radii cannot be negative. So when you think about this, the only numbers that you can input in here are positive numbers, okay? Radiuses have to be positive. They can't even be 0. If you have 0, then a circle does not exist. So your input, or your domain in this case, would be the set of all x such that x is greater than 0, not greater than or equal to, because it can't be exactly 0. Or, I'm going to do this, or you could say x goes from 0 up to positive infinity. Either way you want to do that is fine. Okay, now when you do your range, you guys, and you're talking about areas of a circle, you know that areas of a circle also have to be positive. You can't have a negative area or a negative region. That is not going to work. So your area also will be positive. So you can write it like that, or you could write it like this. Okay? If you plug in really small numbers for the radius, you're going to get a really small area. If you plug in really big numbers for the radius, you'll get a very big area. Okay? So now we are going to kind of go through some different functions here and talk about this. Euler is the one that invented the f of x thing. You guys just know that f of x is the same as y, which is kind of true, but you really need to know that f of x is your output, or what you get as a result of plugging something in to a function. Okay? So here's some examples. We're going to just look at this, not in real world context, but just look at some different functions. Okay? Oftentimes it's really helpful to look at a graph. Okay? Some things that you can do. You always want to be conscious of what kinds of numbers can you plug in. And two things to really be aware of when you do this is that you can't have negatives underneath the radical, and you can't have a denominator that would give you a value of 0. So always be looking for those things. Okay? In this case, there's really no restrictions based on either of those two things. I don't have any fractions, and I don't have any radicals, so I don't need to worry about that. Excuse me. All right, so my domain is what kinds of numbers can I plug in for x? Can I plug in positive numbers? Can I plug in negative numbers? Can I plug in fractions? Can I plug in decimals? Can I plug in 0? That's what you want to think about. And so when you're looking at this equation, what kinds of numbers can I plug in for x? And by the way, this would also be written as f of x equals x squared. Same thing. Okay? I can plug in any single number I want for x. There's no stipulation on what I could plug in for x. So I could write that like this. And you'll see that right there with that funky e in it. And again, this means that x is a real number, or any number that is out there, not imaginary, but any real number. Or I could go like this. X goes from any number from negative infinity to positive infinity. Okay? But now when you think about your range or your output, that's this part. So think about when I plug a number in for x. So when I plug in 2, I get 4. When I plug in 0, I get 0. When I plug in negative 2 squared is also positive 4. When I plug in negative 9 squared is also positive 81. It doesn't matter what number I put in, I am always going to get an answer that is 0 or bigger, because when you square something, it turns it positive. Okay? So your range then will be the set of all y's such that y is greater than or equal to 0 is one way to write that. Or you could say that y goes from 0, including 0, all the way up to positive infinity. Okay? Now, I am going to show you these graphs because I think it's helpful to look at the graphs. This is the graph for y equals x squared, just so you know. And you can see, because you need to remember that these lines go on forever and ever and ever and ever in both directions. So when you're looking for your domain, you're kind of looking for any value that x can be. And I always like to think of if I sort of draw a line that would go on forever and ever and ever, both directions. So I'm going to kind of do this. You need to picture that line going on forever. And I move that line this way, let's say. Is there ever a spot where this pink line won't eventually hit the graph? And again, remembering that that graph, the blue graph, goes up forever and ever both directions. Even if I'm way over here, they'll eventually connect up in the upper left-hand corner. Even if I'm way over here, they'll eventually connect up in the upper right-hand corner, okay? Because things go on forever and ever. It'll be off the screen, but they will connect. So your domain is all reals. And then when you do your range, you kind of want to think of flipping that line the other way. And when you flip it the other way, I'm going to rotate this for us, maybe. When you flip it the line the other way, I'm not hitting the blue graph right now. I'm not hitting it when my values are negative. I only hit the graph when my y values are 0 or bigger. Okay, then eventually they will connect. All right, here's another one. Remember, I always told you that you want to be conscious of you cannot have the denominator be 0 ever. You cannot divide by 0. So this is a problem right here because I cannot plug in 0 for x then. I could plug in fractions, I could plug in decimals, but I can't plug in 0, okay? And then that makes that illegal, okay? So the way you want to record that then is this. This is one way, the set of all x such that x is any number but 0. So x can't be 0. Okay? Or you could record it like this. It goes from negative infinity up to 0 but not including 0, put together with 0, up to positive infinity. Either way is the way to say that it can be any number but 0. However you want to record that is up to you. Okay, now your range, if you kind of think about this, we're going to plug in some really small numbers and we're going to plug in some really big numbers, okay? If I say that x is, let's say, 10,000, okay, then y would be 1 over 10,000, which is obviously a really small number, okay? If I say that x is 1/8, then y would be 1 over 1/8, which then when you flip the denominator becomes 8. If I say that x is 1 over 10,000, okay, then y is going to become 1 over 10,000, which gives you 10,000. Okay, so do you see how they're getting to be really big numbers? The same thing would apply when I plug negatives in. When I plug negative 10,000 in, I would get negative 1 over 10,000. When I plug negative 1/8 in, I would get negative 8. When I plug in negative 1 over 10,000, I would get negative 10,000 as my answer. Okay, so your ranges basically can't be 0 either. Okay, you're never going to get 0 as an answer. So I want to show you this, and I'm going to show you a couple different ways too to look at your calculators. Your range will be any number but 0. So that's one way to write it, or you can write it like this. Okay? That's just looking at the equation. Okay? If you go to graph that on your calculator, it will look like this. And again, you need to remember that this is going to go like this, and it's going to go on forever. And you need to remember the word asymptote. So the y-axis is an asymptote. That means that graph is going to approach that line, but never, ever, ever touch it. And same thing here. The x-axis is an asymptote. So that graph will approach the line, but it will never, ever, ever touch it. So you can see that if you take a vertical line and you move it across, eventually they will connect every spot except for the y-axis. And if you take a horizontal line, it'll connect every spot except for the x-axis. Okay? So that is one thing to use. The other thing that might be helpful is this. If we were to go to our calculators and put in the function 1 over x, like that. And then we were to go to our table. Okay? What I want you to notice is this. Do you see how you get errors at the point 0? So that means that your x value or your domain can't be 0. And then if you pay attention to what your range is doing, and you look at your screen, notice as I'm scrolling up what's happening to your y values. Your y values are getting smaller and smaller and smaller and smaller and smaller. They're approaching, yeah, look at what's happening. And then if you go over here, and you scroll the other way, they're actually getting bigger the other way because it's getting to be a smaller negative, which is actually bigger. But if you scroll this way, your numbers are getting smaller and smaller and smaller and smaller and smaller. Okay? So you can kind of see what's happening as you look at your table too. That is sometimes a helpful tool. All right, here's a square root one. Again, I think I told you at the beginning that you have to be careful because you cannot have square roots underneath, or you can't have negative numbers underneath the radical. So we talked about how when you do this one and you input your numbers, you can't input negative numbers. It'll ruin that function machine. So this one would have to be this. And then, of course, when you take the square root of, when you take the square root of positive numbers, you get positive numbers as a result. Okay, so your range would look like this. We kind of already talked about this one, so I'm buzzing through it really quickly. But that's what that would look like. If you want to use your graph to help you, you would go to your equation, or go to your calculator, I mean. You would go to up to y equals. I'm going to put in the square root of x. Okay, I'm going to hit graph, and it'll look like this. So you can see that your x values are going to have to be positive and that your y values are getting bigger and bigger and bigger as you approach. Okay, you could also use your table, second table. And again, if you use your table and you scroll up here, you can see that your numbers are getting smaller. If we had scrolled the other way, my y values would be getting bigger. And then you can see that I have errors all the way down there. So I can't have x values that are negative numbers. That is not going to work. Okay? So use your graphs, use your tables to help you. There's that one. Okay, and then this. Okay, and sometimes you kind of need to plug some numbers in to think about this. But you know that you can't have, again, negative numbers underneath the square root. I always like to look at kind of what is my pivotal number. And my pivotal number is, in this case, the smallest number I can take the square root of is 0. So my question is, what would I plug in for x to make that value be 0? And of course, it would be 4. 4 minus 4 is 0. So sort of the pivotal number is 4. And I can plug in 4. That's totally fine. Now I want to decide, can I plug in numbers that are smaller than 4, or can I plug in numbers that are bigger than 4? Well, if you plug in 5, then you have 4 minus 5, which is negative 1. And you can't take the square root of negative 1. If you plug in 3, 4 minus 3 is positive 1, and I can take the square root of positive 1. So that means when I plug numbers into my function machine, I'm going to need to plug in numbers that are smaller than 4. 4 is my pivotal number, but I can plug in numbers that are smaller than 4. So my domain would be like this. Okay, or like this. Then you're still taking the square root. No matter what number you plug in for x, you're still taking the square root of it. And square roots will always result in positive numbers. Okay, so it'll be like this. Or like this. If algebraically it's not helping you, then by all means go to your graph, and so go to your calculator, and you would go up to y equals again. Maybe it's kind of being slow here. Let's see, it's not working. Let's quit out of here, see if that works. That doesn't work either. Let's try this again. I don't know what's going on, but it's not working. Anyways, go up to your y equals. This is the graph that you would get for that one, so that you can see your x values are 4 or smaller, and your y values would have to be bigger than 0. All right. Here's another one. Okay. Again, I can't have negatives underneath the radical, so I sort of have to figure out what number would make that 0, and then decide, am I going to plug in numbers smaller than that, bigger than that, or in between that. I sort of have to decide. Okay? So if I think about this, the number that would make that 0, I'm going to just make a little equation. Okay? Clearly, I will subtract 1. Actually, I'm going to add x squared. Okay, so I'll have 1 equals x squared. So then x is going to be either positive or negative, square root of 1. Don't forget to do the positive negative there. Or x is positive or negative 1. So those are kind of my key numbers. Positive 1 and negative 1 are my key numbers. Now I want to decide, can I plug in numbers smaller than either of those, bigger than either of those, or in between either of those? And just try it, okay? Let's say I'm going to plug in negative 2. Well, if I plug in negative 2, then I have 1 minus negative 2 squared. Or 1 minus 4. Well, that's a negative number, and I can't take the square root of negative numbers. So I can't plug in any number smaller than negative 1. Okay? Now I'm going to plug in a number between negative 1 and 1. So if I plug in, let's say 0, that's between negative 1 and 1. 1 minus 0 squared is 1, and the square root of 1 is 1. That works. So I can plug numbers between negative 1 and 1. Now I'm going to plug in a number bigger than 1. So if I plug in 3, 1 minus 3 squared would be 1 minus 9, or negative 8. And I can't take the square root of negative 8. So I can only plug in numbers that are between negative 1 and 1. Okay? So here's how I would write that. It would have to be like this. Between negative 1 and 1 would look like this. Okay? Or it would look like this. And by the way, I can plug in exactly negative 1 and 1. That's okay. Still, when you're taking square roots, anytime you take square roots, you're going to have positive answers. So your range will look like this. Hang on, I'm going to show you this graph so that this makes sense for you. Here's what the graph looks like of this. It's actually part of a circle. So your range actually goes from 0 to 1. Okay? Your range actually goes from 0 to 1. So I'm going to fix this for you. Let's see. 0 less than or equal to y less than or equal to 1. And then your range, or the other way you could write this, I'm struggling here, sorry. The other way you could write this would be to go like this. Negative 1 to 1, like that. Okay, so use your graphs. They really, really, really help. Okay, if you don't know how to do it algebraically, then use your graph. Okay, so the last thing that we have to do is I want to put one on your graphing calculator and kind of show you that sometimes things get all messed up for you on your graphing calculator, so you have to be really careful about this. Now is it working? I think it might be. Nope, it's frozen still. Okay, I'm going to hit pause here, and I'm going to get my thing working, and I'll be right back. Okay, I don't know what's happening. I can't get it running, so I will just have to do this part of it with you in class. No big deal, and we will see you next time.